Okay, so now I have cooled the remaining material in the evaporating dish. Note that it's changed its appearance somewhat. It's much darker than it was. It was all white crystals, and some of those crystals are now sort of brownish, some are still white. But as you saw in the time-lapse video, all the ammonium chloride has been released because it completely stopped giving off vapor, and when I held the stir rod over the evaporating dish, I no longer got any white residue on it, no white precipitate, or I'm sorry, no white condensation. So now I'm going to get the mass of my evaporating dish with what's left. Well, what's left is the sodium chloride and the silicon dioxide. So I'm going to drop all my counters back, and it looks like we're still over 60, less than 66, less than 65, more than 64. Okay. So I'll start moving it out to the 0.95, 0.8. We're getting there. We're in the ballpark. It's getting close to balancing. Move it back to 0.75. We're really close. It's moving up and down. Maybe just a little bit heavy here. We'll move it to 0.7. Okay, and it looks like I need another maybe 1/10 of a gram. Okay, and that is balanced. So the mass of my evaporating dish plus sodium chloride and silicon dioxide is 60.471. I'm sorry, 64. What am I doing? Jeez Louise. 64.710 grams. So from that, you should be able to calculate the mass of the ammonium chloride in the original sample. Okay, next up, separating salt and sand.